Welcome to Scaling with Demi. This episode is brought to you by Peda, a platform that allows you to create virtual schools in minutes.
Hey, hello once again. Welcome to another episode of Scaling with Demi. I think I'm pretty much getting the hang of this recording stuff. And I'm becoming more consistent. So, let's see. Today we're talking about an interesting concept. Something I find interesting, which is the concept of load balancers. I've made reference to it in a couple of video in the past when I talked about monitoring and I talked about scaling. Today I'll be going in depth to some extent into it. We'll talk about some of the load balancing algorithms that exist that can be used. I would also, talk about some of the practical use. Now, note, you probably are not going to need everything I'm going to say when it comes to actually setting up your own tech stack, right? The practical aspect, yes, you might need it. The theory, many of the tools you're going to be using potentially have assumed what would be best for you. So there are very few tools out there that, they might give you the option of extending and configuring, but using the default pretty much works for the most time, right? So yeah, let's get right at it. So what are load balancers? I made reference to it in the past, and load balancers are pretty much useful when you're trying to scale your server, especially within the context of horizontal scaling. If you remember from my last video, if you don't watch it, I think on the channel. But if you do, horizontal scaling is the act of adding new servers, adding new instances. I mentioned instances are like computers, that are processing your jobs. So adding new instances to your application so that your applications can scale. And this mostly happens, say you have your front end here, making requests to the backend. This is your backend. No, don't let me use this. This is your backend, right? You have your browsers or your users. These all represent your users. Let's say 100,000 users. You have your backend, and everyone is making requests to this same backend. But you have when you start processing these jobs, you realize that your site is becoming slower because this guy here, your server, is, let me just make it very fine like a server. Gosh, my handwriting is very ugly on this place. It's a lot finer than this normally. So, you're processing this back to back, and your site is growing, and users are coming in, and you're adding them. And at some point, you realize that this guy is taking too slow. You tried increasing the RAM, increasing the CPU. It works for some time, vertical scaling, right? And then at some point again, you realize that it's still getting slow, and it seems like this server, there's only so much you can increase the server CPU and memory before you have to start adding the server. So what you do in this case is you horizontally scale your backend, right? So you start adding new servers, implementing some autoscaling group I talked about in the previous episodes, right? So now you have 3 servers, and then the front end can now distribute the requests to the different servers, right? So it reduces the load on each one, makes your site faster. If this one a lot faster. If this is busy, the job can go to this guy, and if this is busy, the job can go to this guy, like that. So yeah, it's pretty much an interesting concept. I think we have brushed over this in the past. But then there are now different. But then it begs the question of how does the front end know? How does the front end keep track of all the servers you create? If you've written code before, you're familiar with it. You know that every server has an IP address or a form of recognition system attached to it, a form of address attached to it. And an IP address is attached in a one-to-one mapping, usually, to a domain name, right? So your browser knows, if you are to do this approach, it means that you have to find a way to keep track of all the servers in your front end, right? All the servers that you're going to be keeping up with. So if you are going to be deploying 10 servers, it means you are going to be keeping a record of the IP address of 10 servers in your front end, right? Which is pretty messed up because you could have thousands and hundreds of thousands of servers spinning up depending on how big your product is. So that definitely does not work, right? It's not ideal, right? So the smart guys, they say, oh yeah, so let's come up with something which is the load balancer in this case, right? Which, let me erase this. So we have server 1, server 2, server 3. I'm just making it a little bit less ugly. I'm not sure this is helping. So instead of your front end, which is this, your users, the browser client, instead of it keeping track of all the servers that you are spinning up, note you can even spin up servers in real time. as this workload is increasing using the autoscaling group. So instead of your front end keeping track of all the servers, what you can do is to set up a load balancer here, right? And this is a pretty cool guy. And so what you do is this one has an IP address attached to it or a domain name, and you make requests to this load balancer. And this guy decides, oh, I'm going to give whoever I want I'm going to pass the request on to whoever I want and receive the response and communicate back to you, right? So it's kind of like a middleman. Think of it, oh, I go to a fancy restaurant. Rather than me going to the kitchen to know all the people that are cooking the different food or the different meal, I just talk to the waiter, and their job is to go and help me interact with the servers. Restaurant servers. That's a nice one. Focus, Demi. So their job is to help me go and talk back to the servers, right? So yeah, this load balancer. You talk to it talks to the individual servers on your behalf. Pretty cool, right? Simple. But how does this load balancer now know which one to talk to, which one to route request to? I mean, the load balancer here is the boss, which leads us to the next point, which is different load balancers implement different algorithms. So this is our load balancer here. Fancy bro. These are the different servers. Before going into this, depending on the platform you are using, right? There are different type of load balancers. There is the application load balancer. There is the network load balancer. That's if you're using AWS. Different infrastructure use, different terminologies. For the application load balancer, it redirects the request to server based on certain application property. So for example, you can say, oh, any request that is going to this part, maybe /users/abc should go to this server. You can also say any request coming from Nigeria should go to this set of servers. The benefit of load balancer is not just for even spreading out the request or for scaling. You can also use it to increase the performance by proxying requests to servers nearest to your users, right? So people in Nigeria, they get to use the server in Nigeria. People in the US, they get to use the server in the US, right? So you can say, based on the application property, based on the IP address, you can decide to proxy the application load balancers to the appropriate servers, right? There's also the network load balancers, and these ones, they are contextless. They don't really know much about the application or the cookies on the application headers. They just use purely IP address or some pure static value. But yeah, I won't be going deep into that. Let me just go straight to the algorithms that different load balancers implement. There are different kind of algorithms that are implemented. Some interesting, some a little bit boring. There are the dynamic algorithms and static algorithms. Dynamic algorithms change and make requests to servers based on the properties of the server itself, right? Based on the current state of the server. While static just makes a request to anyone it wishes, anyone it feels like making a request to. So for the dynamic algorithms, and my list is not going to be exhaustive, obviously. For the dynamic, you have the list connection, you have the weighted response time, you have the resource base, so based on the property of the server, you route a request to it. And for the static, you have things like the round robin, the weighted round robin, the IPH, the random, the power of 2. And so basically, for the dynamic, it depends on properties of the server. And for the static, it depends on, whatever it feels like doing. Doesn't care about the property of the server per se. So let me go through it one by one. I will just talk about some of the ones I find really interesting and the basic ones. And for the round robin, as the name says, which the round robin is a static load balancing technique. It just says, oh, you have 5 servers here. I am going to give each of you, I'm going to send a request to each of you in an ordered manner, right? So round robin, I send to you, the next request I send to you, the next request I send to you, the next request I send to you, next request I send back to you, next request I send back to you, and I send back to you. So it keeps going like that in a circular motion, and which is cool. It's one of the simplest you can think of, quite straightforward to understand. But there's a problem with this, in which this server might have received a lot of loads, right, to be processed, or might be handling a lot more work than this server. But then this doesn't care. It just gives it the request to handle. Which means the guy that is the front end that is making a request to this load balancer, in which the request is being proxied to this, ends up waiting longer for his request to be resolved because of this guy is already busy. The load balancer does not know. All he's doing is just saying, it's your turn to take a request. You get a request, and everyone gets a request. That's simple. you know the pro. Is it the pro? Easy to set up. The con, it doesn't really have context as to the state of the server at that moment. It just gives it a request. I mean, it pretty much works for many, but like that's the problem with it. Then there is a weighted round robin, and that one says, oh, because of I want to avoid some of the problems of the round robin, I am going to assign a weight to each server. So I'll give this one maybe 5, this one 2, this one 7, right? And the weight will be based on some of the characteristics of the server. Let's say the CPU or the memory, or say the one I configured an environment variable for this server in particular to process heavy media processes. So I want it to, it's going to be very busy. So I don't want it to be very much used, right? So we assign a weight to the server, a number. And this one says, oh, I'm going to give you more requests than this guy. Because I know, because of you have an higher weight or a lower weight. I mean, depending on how it's configured. Let's just stick to higher weight. So I say, because you have an higher weight, I am going to give you more requests to handle than this guy. You've been configured to do heavy duty work. So let me give you a lower weight, right? So rather than just doing it one by one in a round robin format, it does it one by one still. Rather than you get a car, you get a car, you get a car. It says, you get 1 request, you get 4 requests, you get 2 requests, and you get no requests. Kind of like, you get the vibe of it. So to solve the problem of the round robin, you say, oh, so what if we pick a random, right? I mean, maybe that might increase the chance of a server being picked. I mean, that is busy because of its random, right? But then, on paper, statistically speaking, it's the probability of you picking one that is busy is the same as the probability of you giving a request to one that is busy using the round robin approach. Because if you know anything about statistics, right? If you have 3 items and you have to pick one at random, you know that over a given period of time, you'd have ended up picking every single one equally. Like if you have 3 items, you have a 33% chance of picking this, a 33% chance of picking this, a 33% chance of picking this. The only thing that really changes is the order in which you are picking them. But everything will still get picked. So the random approach doesn't still solve the problem, which now led some nerds, some geeks to come up with something called the power of 2, which I'll talk about at the end of this video because I find it pretty fascinating. But yeah, I still want to go through some other algorithms before I go to this. So remind me if I forget to talk about this. Another algorithm implemented is, so let's say we want our load balancer to have context. I mean, all this is just to make sure that the server scales, our services scale, and we are not having a lot of downtimes. Our website is not slow, right? Our site is not slow. And by the way, so you can appreciate what the tech guys are doing, right? When you see, we're not just writing HTML and CSS and JavaScript and Ruby on Rails. There's actually a lot of interesting things that goes into our job, right? So if you see a tech bro or a tech sis out there, you should hug him. Sometimes we need help. We need hugs, right? So if you see a tech bro, you know that, bro, like you should feel for them. There's a lot of engineering sometimes that go into what they are dealing with. There's also the list connection. So to solve this problem, some guys say, so let's keep a tab of all the connections that are going into the server, right? So when I send a request to you, I store it in a database. I store it somewhere that, you have a connection. When I send a request to you, whether through the round robin approach or to whatever approach for the first time, I store it that you have your request here, right? Then when the server responds, I mark this request as resolved. So you're now free. And this is pretty interesting because what it does is it allows you to determine which server is free and send a request to it. You're not just like guessing that, this guy is going to be free. Let me send a request to it. You can preempt and say, this server is free because of I'm keeping track of all the requests being sent to it. Let me send a request to it, right? If this one is busy, you can pick a new one and send to it, and pick a new one and send to it. And this should solve all our problems and we all live happily ever after. But unfortunately, it creates a problem in which when you have 100,000 servers, right? You have to now keep track of the state of all the servers, which means you have to query your database for the servers that are free, that don't have a lot of requests attached to it, which might now add additional load time to your application, because now your application is processing, is querying. Like all I want to just fetch my profile, but now I now have to query through the hundreds of thousands or millions of servers that have been spawned up, go through the database, wait for it to be updated, say, this guy is free, then I now come back to querying the server itself. So like that's like extra. I mean, extra work, extra load time, right? Because of now we need content, we need to be aware of all the servers. So that did not really solve much of the problem. I mean, it solved it to some extent, but it realized that those are some of the limitations. There are other algorithms that solve this problem. The one I mentioned earlier that I said was pretty much interesting is the power of twos. There's a lot of mathematics. I'm going to dumb it down without the mathematics, too much in-depth maths. There's a lot of maths that goes into it. And I mentioned that very importantly, and I'm saying this from the bottom of my heart, when you see a developer that works on, especially the infrastructure developer or the DevOps or the backend devs, the front-end devs too, they have their problems with CSS and fast stuff. You should empathize with them because it's not easy. Go easy. So yeah, I mentioned the power of tools algorithms. I'm going to continue with that. Just pretty much interesting. And as a quick reminder, we are trying to solve the problem of having to keep track of the state of all the servers, which could potentially add load time to our system, right? I mean, we're all doing this so that our sites will be faster, more reliable, have better user experience. And so if the load balancer itself is taking too much time just to determine which server to send the request to, I mean, that's going to be a problem, right? So this is the load balancer. This is the server 1. All right. My very ugly server. This is the server 2. This is the server 3. All right. And this guy needs to keep track of the hundreds of thousands of servers and their states, how many requests they have, just to query it, add on database, add on indexing, so many complex stuff. So how do we solve that? By making sure, we don't want to do random, because when we did random, there's a likelihood that you pick a server that is still busy, right? So we don't want to do random. At the same time, we don't want to keep track of everything to know which one is not busy, which one is busy, because that adds extra computation time, extra request time, extra load time to the processes. Right. So how do we, so they came up with an interesting process, right? Which I think is pretty much fascinating, which is you pick 2 servers at random. I mean, so before I even talk about picking 2 servers at random, if you have 3 servers here, right? And you pick at random, the probability of you picking, if one of them is busy and the 2 are free, the probability of you picking a busy server is 1/3. The probability of you picking a free server is 2/3. I mean, probability, simple mathematics, right? If 2 of them are busy and one of them is free, the probability of you picking a simple server is a free server that is not too busy is 1/3. The probability of you picking a busy server is 2/3. 2/3, right? Same thing if everything is free, the probability of you picking a free server is 1 and vice versa, right? We need to make it way more efficient, right? So we say, oh, don't forget, 2 are busy, 1 is free. Probability of busy, 2/3. Probability of free, 1/3. So what if we could pick 2 servers at random? We don't know the state of the server, right? We don't know the state of the server. So let's say we pick 2 at random, right? Then we now check between the 2 of them, which one is busy, which one is more busy. Then we now assign the request to the one that is less busy among the 2 of them. So that solves the problem of us having to query through all the servers to see which one is free and sending a request to it. Now we can just pick 2 at random. So let's see what the maths become, right? So if you're going to pick 2 at random, you can either pick A, B, or you pick A, C, or you pick B, C, right? A, B, A, C, or B, C. You're picking 2 servers at random, right? What that means is, just believe everything I say now. If you understand really the math and I'm wrong, just let me know. I do not really think through this so deeply. So just let me know. If you don't understand math so deeply, I don't know, take it like that. Or you do your own research and let me know in the comments or tweet at me the correct thing, right? If you pick A, B, 2 of them are busy, so you get a busy output, right? If you pick AC, 1 of them is free, so you get a free output. If you pick BC, 1 of them is free, so you check which one is lesser, right? You get a free output, right? So you have busy, free, and free, right? So the probability of you picking busy in this case becomes 1/3, and probability of you picking free in this case becomes 2/3. Simply because so you can see 2/3, you're more likely is greater than 1/3, which means you're more likely to pick a free server by using the power of tools than the former approach. I don't know if this made any sense. Let me take it again for those that didn't really understand it well. I'll clean everything. I think there should be a way you can clear on this thing. I don't know. Let me just go to a new site. Okay, so we have the load balancer here. Right? You have 3 servers. Right? This is busy. This is busy. This is free. Note, the goal is to pick a free server, right? The goal is to pick a server that is free. So you can send a request to it. So the request can be handled very fast, right? That's the goal. But then the load balancer does not know which of the server is free. And it doesn't want to spend a lot of resources and compute time and energy querying all the hundreds, usually it could be hundreds of thousands of servers you have been deployed. It doesn't want to spend that querying each of all the instances. So it picks one at random. If it picks at random, right? The probability of it picking a busy server is 2/3. That's because it could either pick A, B, or C. It's picking only one out of the 3, right? If it picks A, busy, the probability of it picking, because they are too busy, right? The probability of it picking a busy server is 2/3. And the probability of it picking a free server is 1/3, right? Because there's only one out of the 3 that is free, one out that is busy. So maybe this is a way to, two of them should add up to 1. Probability, simple probability, right? But if you pick 2 servers and you find which one is less, right? You pick 2 servers at random and you find which one is free among both of them. Let's see the probability we now have, right? 2/3 is definitely greater than 1/3, which means you're more likely to pick a busy server in this case than this case. But then if you pick 2 at random, right? You can either pick, so let's say this is A, this is B, this is C. You can either pick A, B, A, C, or B, C, right? So the probability of you picking, if you pick A, B, you have busy because they are both busy. So you don't really get much benefit. If you pick A, C, and one is free, one is busy, you'll find which one is freer in both of them, which one is using less resources. So you realize that it is C. So you can get a free as the output. Because if you have busy and free, you definitely pick the free. For the A, B, 2 of them are both busy. So, this minor one is always going to be busy. And for B, C, you are free. Consider the probability changes so busy becomes 1/3 and free becomes 2/3. So you're more likely to pick a server that is free. Now, this is just 1/3. This is just out of 3 servers. Imagine you have thousands or hundreds of thousands of servers. The larger the servers, the number of instances you have, the larger the number of instances you have, the more the likelihood of it, the more the differences between the random choice and the power of 2 random choice becomes. And you can do this for n number of servers. It doesn't have to be power of 2, it could be power of n number of servers. I'm not just sure the benefit you gain from it scales linearly as you increase the number of servers you select from. So that's one I said was interesting. In retrospect, it might not have sounded as interesting as I thought it was going to be. But I've attached a link to an academic paper on this by some Harvard researcher. There are a lot of other resources on the internet that talks more about it. And there are other approaches you can take. There's the IP hash, and which says, for the first request that comes into the load balancer, let me clean all this, right? The first request that comes into the load balancer, I would, using any of the previous mechanism we've said earlier on, I determine a server to send it to, right? But I hash the IP address. Now, usually a client has a unique IP address, right? So I hash the IP address. So if you're coming from 192. Okay, let me just use 127.0.0.1. This is usually local, but for the purpose of this conversation, I'll use this. Ouch. 127.0.0.1. Is that it? Yeah. So I hash the IP address and I map it to also the destination IP address. I hash it. Right? This is the client. This is destination. Let's say some random other IP address. I kind of find a unique string from the combination of both. So when the exact same client sends a request, I proxy it to that server in particular. I don't proxy it to any other server. and you make a request to that same server. So once you've made the one request, the same user is going to be hitting that same server. So if at all the user makes a request, the advantage of it is, you don't have to spend much time determining what server to proxy a new request to. And usually a browser makes like multiple requests just for one instance. When you load Facebook, you're probably making tens, hundreds of requests just to load your profile, load the images, load all this data, right? To different servers. So this one just keeps maintaining the connection. But another benefit of this is if you're using sockets and you're using, I think the long polling approach, it makes it easier to deal with, because sockets, you don't have to be establishing a new connection whenever you connect to the server all over again, right? You can just reuse that same connection, right, from the front and the back end. Sockets is another discussion entirely. I don't go too deep into it. So you can use that. That's another approach. You map the IP using IP hash and the destination hash, and you map it to a single server. Let's say for like a particular time frame, and after that time frame, the hash expires. So when the exact same IP makes another request, either you still use that request or you create a new request. The downside of this is during the flow of the request, if the server has an issue, this guy might still experience a bad issue, but other people are fine. Right? Other people can just keep making requests to different servers. That's it for this episode. I hope it wasn't too technical, too boring, and I was able to explain some of this concept to some extent to you. I will try to make the next one less technical, except you tell me otherwise. I will try to make it more product, more simpler approaches. Stay tuned. Have a nice day.